Hello student, in this lecture we are going to study about exponential inequalities. Exponential inequalities has an integral part in mathematics and in your algebra, trigonometric and even your calculus is incomplete without exponential inequalities. Your log inequalities is can't be understand without the getting the concept of exponential inequality. So without any further ado, let's get started. As we know that your exponential function show dual nature around unity. So say if I have any input which is greater than 1, let me call it as a 2. If 2 is there, then I need to establish a relation in its index 2 to the power x. If it is greater than 2 to the power y, then how I'll establish a relation in x and y. This is the meaning of your exponential inequality. If the base are equal, then we may compare its index. As we know that its base is greater than 1, then this is how the graph of your function will look like. It will be increasing function. And what is the meaning of an increasing function? A greater input will bring a greater output. So if 2 to the power x, it's a greater output, and it is given that it is greater than 2 to the power x, then what may be the reason behind that result? The result is clear. It is that your input x should be greater than input y. Similarly, say if I have any number which is greater than 0 but lesser than 1, let me call it is a 1 by 2, and I'm trying to establish a relation this time in this inequality that 1 upon 2 to the power x, let us say it is greater than 1 upon 2 to the power y. As I know, if the base is between 0 to 1, then this is how the exponential function will look like. And in that case, your function is decreasing. What do I mean by decreasing? Decreasing in that sense, for the greater input, it will bring a smaller output. So for x2 greater than x1, for this one we have f of x2 will be lesser than f of x1. So there 1 upon 2 to the power x is greater than 1 upon 2 to the power y. That means what should be the relation between x and y? Your x should be lesser than y, correct? So for greater x in greater values than x will bring the smaller value in its output. So now let me take some more couple of questions over there. In this one, we have 2 to the power some variable x square minus x, and it is given that this expression is greater than 1 upon 2 to the power negative 2. So the first thing is that their base are not equal. We have a 2 on a side and 1 by 2 on the other side. Is there any way you can correlate their base? Of course, it is that you can write your 1 by 2 in 2 to the power negative 1. Even you can do the same thing with 2, but we should need to start with some reference. So say I'm writing 1 upon 2 as a 2 to the power negative 1 whole to the power negative 2. Now this expression, your left hand side is will remain the same, while your right hand side is equals to 2 to the power 2. Now remember the base over there is greater than 1, and you need to check for what input it does occur. So there we have x square minus x should be what? Should be greater than 2, correct? Now bring this 2 on the left hand side. We have a quadratic inequality which is solvable. Factorize this equation and you have your solution. There we have x minus 2 times x plus 1 should be less greater than 0, which said that the values of x should belongs to negative infinity to negative 1 union, excluding 2 up till infinity. But the critical point will not be the part of the solution because equality is not what we are looking for in the question. To understand exponential inequality further, let me take another example. And this time we have a 2 by 5 to the power x minus 2 over 1 minus 2x. On the other hand, we have 25 by 4. So to establish a correlation in its index, you need to equalize their base. So just try to establish a relation in 25 by 4 with 2 by 5. As I know that 25 by 4, it is nothing but a square of 5 by 2. Is there any way you can represent this 5 by 2 in terms of 2 by 5? Yes, it is. You can write 5 by 2 to the power 2 in 5 by 2 to the power negative 2. So try to replace your 25 by 4 in terms of 2 by 5 to some power. So there we go. We have 2 by 5 to the power x minus 2 over 1 minus 2x. It is lesser than or equals to 2 by 5 to the power negative 2. Now, once we equalize their base, now it's time we can create a relation in its index. So there we go. We have x minus 2 over 1 minus 2x. This should be what? That should be greater than or equals to negative 2. Why? Because the base is between 0 to 1, and that should be the relation in its index. Now bring this negative 2 on the other side. Please do not cross multiply both the side because you are unsure about its denominator. What will it be? It may be positive for some values of x, it may be negative for some values of x, even it can be 0. So it is advised to bring this negative 2 on the other side, and we have this inequality. Take the LCM and solve its numerator part. We have x minus 2, positive 2, and then negative 4x over 1 minus 2x should be what? It should be greater than or equals to 0. In the next step, try to make the leading coefficient positive. So in numerator, we have negative 3x. So I can write this negative 3x as a 3x times negative 1. And in denominator, we can write this 1 minus 2x as a negative 1 times 2x minus 1. Should be what? Should be greater than or equals to 0. This negative will get cancelled out from this negative from denominator, and eventually I have the values of x. X should be what? X should be negative infinity to 0. 0 is included this time. Union 1 by 2 up till infinity. Now do let me know whether this 1 by 2 would be a part of the solution or not. Since this 1 by 2 is a critical point belongs to denominator, and we don't count any critical point which comes from the denominator, because this 1 by 2 will make your denominator a 0, and we don't want to mess with these numbers. Now, here is the conclusion time for all of you. Say it is given that n to the power x, it is greater than n to the power y. If number n is greater than 1, then what will be the relation in x and y? Absolutely right. In that case, your x should be greater than y. Sign of inequality will remain the same when our base is greater than 1. Now, how about when base is between 0 to 1? How would you establish a relation in x and y this time? This time, the sign of inequality will change while you make a relation in its index. I hope this help you out to understand more about exponential inequalities.